Okay, so we're doing law of sines, and like I said, this is no longer right triangles. It's also not the unit circle trig that you're going to get into later. So this is still very manageable trig, but not with a right triangle anymore. But still showing you how the relationship between angles and sides applies when we don't know how to find it some other way. We can always use trig to find a missing angle or a missing side. In this case, using what's called the law of sines. And the law of sines can be used when you have an AAS set up in a triangle, when you have an ASA set up in a triangle, or when you have an SSA set up in a triangle. So the donkey one, right? If you can give it the SSA, ASS setup, you can use this law of sines to find all the other missing sides and angles in a triangle, okay? So I'm going to give you the law of sines to start, and then we'll show you why we can do it. I'll give you a little proof of it, and then we will use it. So let's say we have triangle ABC. Across from side A, or across from angle A, excuse me, is side A. Across from angle B is side B, and across from angle C is side C. Okay, so here's what the theorem says. The ratio of the sine of an angle, so sine A, sine C, sine B, the ratio of the sine of an angle and its opposite side will always be constant in any triangle. So whatever the ratio is for the sine of an angle to the side across from it will be proportional to every other sine of an angle to the side across from it. In other words, I can say sine A over A will always equal sine B over B and sine C over C. Okay, so if I'm missing a piece, but I have AAS, ASA, or ASS, I can find the missing piece by using this setup, okay? Let me just show you a proof of why this works. I'm not gonna ever make you do this. I want you to understand why it works, okay? So this is just you understanding why we're able to do this setup. So I'm gonna draw that same triangle again with a few extra pieces. So we're gonna draw in a height, and then it's still triangle ACB, and then we have A, B, we don't even need C on this one. Excuse me. Okay, so let's do this. If I'm looking at angle A, can you tell me what sine A is right now in the right triangle? So if I'm from this angle right here, sine A is opposite over hypotenuse, so it's what over what? H over B, right? Because we're using this right triangle right now. Okay, so sine A equals H over B. What does sine B equal right now? H over A. Here's your right angle, right? Now we're looking at that right triangle. So sine B equals H over A. Okay, so what if on both of those I were to solve for H? Okay, so on that first one, if I want to solve for H, I would multiply by B on both sides so that this cancels. So now I have H is equal to B sine A, right? But if I solve over here, I would multiply by A. So now I have H equals A sine B, okay? What do you know about those H's? They're the same, okay? So if that's the case, I can say right now that B sine A equals A sine B, okay? And if that's the case, if I divide by the same thing on both sides, does my answer change? No. So I'm going to pick a convenient thing to divide by on both sides. If I divide by AB and divide by AB, what happens is my B's cancel here, my A's cancel here, and what I'm left with right now is sine A over A is equal to sine B over B. And that's the law we just learned, right? That's the law of sines. So this is why law of sines works. Even though you won't be given a triangle with a height in it, if you were to draw that height in, you could do that every single time, okay? So we're not just pulling a random law out of nowhere. That is why the law works. Here's how you will use it. First example, let's say you have, and this is not necessarily drawn to scale here, but you'll have the right pieces anyway. So this is NLM, and we're going to say angle L is 125 degrees. This is 11.4. This is 28 degrees, and this side is X. Okay, so essentially what you're looking for is one of the 3 types of triangles that we talked about earlier. In that list that we gave, there was AAS, ASA, and SSA, right? Well, if you look at this picture, it goes angle, angle, side. So we have the AAS set up. Really what I always look for, I don't even look for those types of triangles. I look for, do I have an angle with the side across from it and another angle with the side across from it where I'm only missing one number, okay? Which I have here, okay? So here's the setup. It is sine A over A equals sine B over B. So if I say sine 125, what is the side linked to that? X. So we're gonna say sine 125 over X, and then sine what? 28 over 11.4. Okay, so it's always going to be angles attached to the sines and sides underneath it that are related to it. Okay, how do you solve that? Cross multiply, right. So if we cross multiply this, I always put this in front of the sign just to avoid issues with parentheses. So it's going to be 11.4 sine 125 equals X sine 28. Okay, that's cross multiplication right there. How do I solve for X? Divide by sine 28 and divide by sine 28. Now here's the deal. For some of you, you're going to want to do it this way. You're going to want to plug this in and just hit enter, okay? Then once you have that number on your screen, then you're going to divide by sine 28, and that's great, okay? For others of you, you want to plug it in one foul swoop. Well, if that is you, here's how you need to plug it in, okay? If you're going to plug it all in as one thing, you need to plug in 11.4 sine, and then your calculator most likely starts a parenthesis there. You need to do 125, and you have to finish that parenthesis. If you don't finish that parenthesis, you will get the wrong answer, okay? Then you can hit divided by, and then sine 28. So if you're going to plug it in all as one thing, you must put that parenthesis in. If you're going to plug it in separate, then you can do 11.4 divided by sine 125 and hit enter, and you would get 13.917, okay? Because that's not our final answer, give it 3 decimal places. Go to the nearest thousandth, okay? And then divide by sine 28. So it's totally up to you. I don't care how you plug it in, but you have to figure out what works for you, because if you miss this parenthesis, you're going to get it wrong every single time. Okay, so if you want to play it safe, go this route where you hit enter and then divide by sine 28, and you should get as your answer something didn't work out for me there. Oh, I divided. 11.4 sine 125 is not 13.9. Sorry, guys, I divided. This number should be 9.338. My bad if I just threw you off there. So if you did it that way, 9.338 divided by sine 28, and you get to the nearest tenth then, x would be approximately 19.9. Okay, so maybe try that out real quick on your calculator and see which way you prefer it, and get used to doing it that way then. Okay, are there any questions on that one? All right, second one. Let's say your triangle looks like this. This is x, this is 9, this is 13, and this is 43. Okay, notice now it's your angle that's missing. So this is a little bit different. Can you give me the setup? So we know it's sine A over A equals sine B over B. And people always ask me, is it always going to be sine? It is always sine, okay? You will never use cosine, you will never use tangent in the law of sines, okay? It's always sine. So can someone set it up? Sine what? Sam? Right, so sine x, real quick, x is across from the 13, right? So sine x over 13 equals what? Right, sine 43 over 9, right? The 43 is across from the 9. And then you'll cross multiply it. So cross multiply this, you get 9 sine x equals 13 sine 43. Okay? At this point, you have an option again. You could plug 13 sine 43 in and hit enter. Okay, so if you plug in 13 sine 43, you would get 9 sine x equals 8 point, again, do nearest thousandth, so 866, okay? Then you would divide by 9, and again, nearest thousandth, so you get sine x equals 0.985. How do I solve for x? The inverse, right? You need to take the inverse. So x is going to equal the inverse sine. And if this is the last thing on your calculator, you can just type in the second key and then answer or entry. There's a button on your calculator. If you don't know where that button is, ask me. It will save you so much time, okay? But if you do the inverse sine of that answer, you should get to the nearest tenth here. Actually, we'll do nearest whole number because it's an angle. X would be approximately 80 degrees. Okay, so pay attention. If you're solving for an angle, you have to use the inverse as your final step. Okay, if you're solving for the original, then you're just going to plug it in as is. I got one more. We'll set it up. Last example. If we don't get through it, at least you got the setup of it. Let's say this is your triangle, and this is x, 44, sorry. 44 degrees, 50 degrees, and 13.8. Okay, here's the issue on this one. You have an angle, but you don't have the side across from it. And then you have an angle, but you don't have the side across from it. It's your variable. Do you see a way that you could still use law of sines right now? Sam? Right. So if it doesn't look like law of sines is going to work, you have two of the three angles. So you're just going to go 180 minus 50 minus 44 is 86. Okay, so find the missing angle. And now you have enough information. So 86 and 13.8, so it would be sine 86 over 13.8 equals, and then which angle are you using? The 44, which is across from the x. So sine 44 over x, and then you can cross multiply that. So 13.8 sine 44 equals x sine 86. And this is like that first one again, just be careful with parentheses. If you want to plug that in right now, you can. Or if you want to plug it in all in one shot, you can. What do you have to make sure of if you plug it all in as one step? The parenthesis that goes right here, okay? So 13.8 times sine 44, end that parenthesis, and then divided by sine 86, and you should get to the nearest tenth approximately 9.6. Okay, but that parenthesis will make or break you in this, and if you don't show me work on this, I can't give you credit. So make sure you show me every single time what you're plugging in, how you're setting it up, so that I can give you partial credit if you plug something in wrong. Okay? Questions on that?